Okay, today I would like to walk us through how to solve LeetCode problem coin change 2. And this problem essentially asks us to use a specified number of coins to make up, to sum up to the given amount. In this case, amount is 5, and you can choose coins from number 1 to 5, and you can use each of them as many as times you want. So this is really combination problems, and it's very important to differentiate the combination versus the permutation. And combination essentially means that 2 plus 2 plus 1 making up 5 is considered the same as 1 plus 2 plus 2. These two will count as only one solution. That's why this problem output is 4, the unique way of making that number 5. Otherwise, you will have more than 4. Understanding that is very important, and then let's go working this problem out. So this problem itself falls into the category of dynamic programming. For dynamic programming type of problem, it's very important to write the correct transfer function. Why do I know that it is a dynamic programming problem? Because to solve the unique number of ways of making amount of 5, and to use 1 to 5, if I know how to solve number 4, right, I will know how to solve number 5 because it's just plus 1. And if I know how to solve number 3, I know how to solve number 5 because this is just plus 2, right? And if I know how to solve number 0, I will know how to solve number 5 because it's just plus 5, right? But only knowing this just indicates you this is a dynamic programming problem. You still need to figure out how to write the transfer function. And there is a pitfall. So if we try to solve the number 5 by solving number 4, and then by solving number 3 by number 0, we will fall into a pitfall tends to solve this problem as permutation. You will see why in a second. So for 0, right? If let's define the DP first. So let's define DP0 as make up amount equals to 0. Number of ways, and this we know it is equals to 1, right? You just use no coins, and we know this is 1, so we already know there's already one approach to solve number 5. Just use coin 5. And for number 3, there is ways of again using coin 1, which is DP1, and then there's ways of using DP coin 1, and there's ways of using coin 2, right? So in this way, we know this one is 1. This one is actually can be further decomposed to 1 and DP1. And in this case, 1 and 2, 2 just plus 0, and 1 just plus use coin 1, right? So this is another approach. So 1, 2, and then 3, 4, and you will see that here we have already have 4, but we haven't expand this yet. The issue is that if you are calculating combinations, there's only 4 solution according to the example. What did we do wrong here? I will pause for a second. So you will see that here we used number 2, right? Here we used number 2. Here we used coin 1, so 1 plus 2 plus 2. And here we used number 2. And then here we use number 1. And here we use number 2 again. So 2 plus 1 plus 2. And we have already talked in above session that the permutation actually treat 2, 2, 1 and 2, 1, 2 as different solutions. That's what we are doing here. So we fall into a pitfall to solve a combination problem using a sort of permutation type of approach. But we are good in a sense. We realize this problem is a DP problem. To solve number 5, we need to solve number 3, and we need to solve number 0, etc. The only tricky part is how to formulate this transfer function as a combination problem. And to solve DP problem, we finished the first step for defining what is the DP. DP5 would be just a number of ways to make up amount equals 5, right? We're calculating in this case. We from the example we know this is 4. And then next step we write transfer function. The trick is that we need to force the sequence of the coin. So we need to put the coin in the outer loop. So which means in this case coins 1, 2, and 5, and then we want to calculate the amount in range of c minus c up goes up to amount plus 1. Because range doesn't include plus 1, it will stop at amount, which is what we want to calculate. And if we want to calculate the amount, we want to write the transfer function, and it will be equals to itself plus the contribution from the a minus c, right? That's exactly borrowing the idea we had here by solving 5. In this case, by solving amount a, we need to solve the a minus c. But the subtle difference here by putting the for loop of coin above is that it implicitly defines the sequence. So you will only use 1 at first time when this iteration starts. When c equals to 1, it will calculate the impact of c being 1 here, and then c will never be 1 again, right? For number for a equals to 5, for example. And then next time when outer iteration goes, when c equals to 2, it will calculate number 2 here, and the number 2's impact, c being number 2, the impact for a equals to 5, and then c equals to 5. So there will never be a case where c is first equals to 2 and then c equals to 1, which is essentially what we did here by use 2 for again after we might use 1 here and then use 2 somewhere there. So just want you guys to remember the trick here. This needs to be, you can just memorize it by adjusting the sequence of the for loops this combination becomes like actually this becomes combination problem, where that one was essentially what we are doing is like we put the for a in range, say to amount plus 1 at the outer loop, and then we were like kind of putting for each amount. Actually we write 0 here, and then say equals coins. What we were trying to do is like for each of a, in that case it's number 5, we are trying to figure out all the possibilities to select 1, 2, and 5, and it goes from there. So this type of solution will lead us to the permutation, which is not this problem is originally asking for. So what's the invariant? Which means that if you remember this, you will be able to solve this problem yourself next time. First of all, DP problem might have two types of problem. One is asking for combinations. The other is the permutations. And all these will be actually determined by a sequence of for loops. If you remember this, you will solve this problem next time. Thank you.